Hello everyone, in this video we'll see Kruskal's algorithm for finding minimum spanning tree in a graph. We all know what is a minimum spanning tree. In the last video we have seen how to find a minimum spanning tree from a connected and weighted graph using Prim's algorithm. So in this video what we'll do is we'll solve the same problem, the minimum spanning tree problem, using Kruskal's algorithm. So let us first recall what is the minimum spanning tree. Let us consider a connected and weighted graph having a v number of vertices. What we need to find is we need to find a tree with the vertices minus one number of edges so that it becomes the minimum spanning tree. And the most important thing is the minimum spanning tree must not be cyclic. If it is cyclic, it's not a tree. So if the number of vertices of a connected graph is v, we must have v minus one number of edges. That is called a minimum spanning tree, and it must not be cyclic. It should be acyclic. So what Kruskal's algorithm states is, the way the Kruskal solve this minimum spanning tree is sort the vertices and edges using weights. With respect to weights, sort the edges and vertices with respect to the weights in the ascending order, and then first take the minimum or the less weight edge first, and then go for the next less weight edge. Try to add that edge, add that edge or add that vertices to the tree. Check whether it is making a cycle or not. If it makes a cycle, remove the edge. If it's not making cycle, add that edge, and then next go for the next smallest element. Check whether if you add that edge or that vertices, if it is becoming cyclic, then remove that edge. If it's not becoming a cycle, add that edge. In the same way, repeat the process. Go for the next minimum, next minimum, next minimum. Try to add it. If it's becoming a cycle, remove that edge or else add that edge. So for that, what we'll do is we'll use a data structure called disjoint data structure for finding minimum spanning tree in Kruskal's algorithm. So we'll see in Python what is disjoint data structure, how to implement the disjoint data structure. You must have studied disjoint sets in maths. The same process we are going to implement in Python. That's it. They'll be having three parts in those disjoint data structure. First, we'll be having a parent, finding, and then union. So that way we'll find the minimum spanning tree using Kruskal's algorithm. So you can see the algorithm here. First we have to make a set, and then we'll be having a parent vertices with parents with array, and then find the set and then union the set. That's all. So let us see how to do it in Python now. So for using the disjoint data structure or the disjoint sets, I have created a class called disjoint set, and then I have created an array called parent. So what this parent array will be holding is, it will be having an array or a pointer. It will be having a pointer to each and every vertices or each and every edge. What is the use of this is, when you add the whole vertices or the whole edges to the tree, and if you come back to the main root, that pointer, if that parent node is representing to its own root, then if both the values are same, then it means you have come to the root node, then it is the end. That's all. So to know that, we'll be having different pointers or different values for each vertex or each edge. And then I have told you before, we'll be having three parts in disjoint set data structure, implementing the disjoint sets. First one is making a set. First we have to make a set with parent vertices, parent array, and implement those values to within the range of n. So first one, for example, in this case it will be, if I take from 0 to take n as 5, or in this case I am taking n as 7 here, what we'll get is 0 to 6, 0 to 6, 0, 1, 2, 3, 4. Each will be having, each root or each node will be having a different, each vertices will be having different values, its own values. So I'll make a set first. I'll make a set, and then to find whether the element or the edge belongs to the same vertex or same vertex or not. I have to find. If it's not present in the same vertex, then I have to add that edge to the same set or the same vertices. And if it is not in the same set or it is not in the same vertex, then what I have to do is I have to union, take a set, and then I have to add this finder set into my union. That's all. So for doing union, to combining the vertices, I am using this union function, and to find whether it belongs to the same vertex or it is from the different set, I am using find. And then for making a set first, I am using this function called make set. So this will perform all the operations here, and then it is a main algorithm. We come to the main algorithm, Kruskal's algorithm. So I am passing here edges as an input, and n is my size. N I am passing here. And now I am creating a MST. I am creating a minimum spanning tree, and I'll append the values into this MST based on the vertices and the edges found in this set from this algorithm, from this class. Here for that, what I am doing is I have created object for the disjoint class, disjoint set class here, and then I am calling the make set function in order to make this many number of this n sized parent array, to have different values for each vertex or each edge. And here I am initializing index to 0 while length of MST is not equal to n minus 1. Then I have to loop into the array, and we will be having three values called source, destination, and weight. You can see here source, destination, and weight. So from which vertex to which vertex the edge is there, that means where the edge is there, and what is the weight of the edge. So that is what we will have in a weighted graph. No, same thing. So for that I will have three values: source, destination, and the weight of the edge, and I am passing it to the edges of edges array. And then for each iteration I will be incrementing the edge, so that it will check for all edges. It will find whether the source and destination are of the same set. If they are not of the same set, then we have to append the source, weight, and destination, and then we have to do the union. I have told you in the beginning, if they are of the not same set, then combine them into the same set. For that is what I am using this union function. Make them into the new set and then append. For that, and then I am appending them into the source, into the MST, my final result MST. That's all. The same way. First it will go for the first one. Second one it will check whether it's making a cycle or not. If it is of the same set or same vertex, then it will add, or else it will remove. That's all. So finally what I am doing is I am printing the edges and weights from source, destination, weight in the MST. So when it's not, what I will do is when it is not forming a cycle, if x is not equal to y, then I'll append the source, destination, and weight into my tree, so that in this way it will be adding each edge in each iteration. It will be adding each edge if it is not forming a cycle. If it is forming a cycle, it will leave, so that in that way, if my n is 7 now, here my n is 7 in this case, so I will get n minus 1, that is 6 sets I have to get. So you can see here 1 2 3 4 5 6. For example, if I give 8, or I change the values to 8 or 9, then b minus 1. We have to remember, if there are 7 vertices or 8 vertices or 10 vertices, any number of vertices, v minus 1 number of edges will be there. So that is what we will get here. So for example, I will run the code and see. So you can see the output here. 0 to 3 one edges and the weight is 5, 2 to 4 one edges and its weight is 5, and 3 to 5 another edge, its weight is 6, 0 to 1 another edge, its weight is 7, 1 to 4 another edge, its edge is 7, 4 to 6 another edge, and its weight is 9. And that's all. See, I have given the input, hard coded the input here. You can take input from the user also. And then I'm using, as I have told in the starting, we have to sort the values according to the weight. These are my weights: 7, 8, 3 are my 5 are my weights. So 2 is the index, 0, 1, 2. So according to this values it will sort, according to the weight values it will sort. So for that I have used the sort function here, and then I have given my number of vertices, and here I am calling the function and passing the argument and printing that MST. That's all. Thank you.